fourth of a series of short talks I've been giving about the piping life cycle. And what this refers to is the transitioning of piping data from a 3D model into a physical and operating plant. We've already covered the stages of what happens in design, work preparation, and fabrication. And we've seen the important concept that the data that originated in the 3D design model has flowed through the whole system. We've tried to avoid re-entering information or copying information, transcribing information. We've tried to use the data as it is and to add to it, because that's going to minimize error and produce a better quality result. We've seen how the piping data for things like temperatures and pressures and flow has driven the requirements for welding, for testing, and how we've, in the pipe fabrication shop, how the instructions for fabrication have been transmitted. So now we've reached the final stage. We are going to construct this pipeline. And what we're starting with is a whole bunch of spools that have been fabricated in the shop and delivered to site, and a whole bunch of material that is required for erection. So these are things like gaskets and bolts and perhaps valves that are not part of any spool, but was in the original isometric. So material management, procurement of material, ensuring that material is available on time is a key thing. But also a key thing is that the spool is now the kind of minimum unit that we're looking at. We're going to assemble these spools and this erection material into the line. We don't really care too much about how those spools are made up. And in some cases, this is taking place on site, and in some cases, this may be a further stage in the workshop where we assemble this into a module, but it's basically the same principle. Now, the interesting thing here is we're now on the construction site, and the work content is now driven by the original issue for construction isometric, the erection drawing. So this is the whole pipeline, and it shows us how the spools relate together and how to assemble them. So it's our job to take 2 or 3 of these spools, some of this erection material, we're going to make this pipeline, and almost certainly we're going to have to do some welding in the field. Now, welding in the field, different proposition, particularly if the weather's bad, it's uncomfortable, it's more costly. So we want to minimize that. And that's all about optimizing the process. But if we're welding in the field, we have many of the same issues that we had in the fab shop for the welding. We need to know what sort of weld to do. We need to know the conditions, how to prepare the weld and the 2 ends to be joined, what quality control is necessary. And equally well, we need to report progress. We need to make sure that everyone that we're working for understands where we're up to. Are we 50% the way through, 20% the way through this process and all the steps we have to take? So at this point, we can assemble a whole series of lines. Now, if we track right back to the beginning of the process in the 3D model, you'll remember that we split the 3D model up into these ISOs, into these sheets on the ISO. And we pointed out that the sheet was kind of an artificial and strange concept to drive this construction work process. And actually, typically, even the line level is not enough, because in terms of commissioning and operation of this line, we're probably interested in an assembly of lines into a system that does something in particular. When it comes to commissioning, we might need to test 3 of these pipelines together as a circuit or a system. We need to test, to pressure test, we need to pressurize the system and check it for leaks. Maybe we need to flush it out to ensure that it's ready for operation. So the system is an assembly of lines, and there's a further stage of making sure that the system as a whole is certified and documented and is ready and can be signed off eventually for handover to the owner-operator, who is going to operate this plant, who needs documentation, he needs the history, the audit trail, he needs to understand all the decisions that were made, because in the unlikely event that something goes wrong, you need some traceability to come back to it. But in essence, what we've done at this point is replicated the 3D model that we started with in the plant, and it's ready to go, and it's good for the next 50 years. So that's the end of this series. I hope you've enjoyed watching this process of the piping life cycle. Thank you.